Today in this video, I'm going to be talking about limits. So your first question might be, what is a limit? And that is an excellent question, but before we talk about what a limit is, we have to talk about what we're defining a limit with regards to. So the first situation we'll look at is defining a limit with regards to a collection, or in this case, a sequence of numbers. So say we've got the sequence of numbers 1/2, 1/4, 1/8, and 1/16, and so on and so forth. So we have these numbers that are being divided by 2 for each value in the sequence. And so if we have this sequence of numbers, we can also define it as the sequence 1 over 2 to the n, for n equals to 1, 2, 3, and so on and so forth. So, examining this sequence, we can see that the numbers are getting smaller and smaller and smaller. For example, the number 1 over 2 to the n for n equals 100 is going to be the number about 7.8886 times 10 to the negative 31. Now that's a very, very small number, but it's not actually 0. None of the values in this sequence are actually 0. So we can't say, this limit is, or this sequence is going to be equal to 0 for any value in the sequence. But what we can do here is use the concept of a limit to define what this sequence, the values of the sequence are approaching. So what we can do is to say that the limit of the sequence as n goes to infinity of the sequence 1 over 2 to the n is equal to 0. So here we've done something very powerful. We couldn't say that any of the sequence values were exactly 0, but we can say that their limit is 0. They are going to get closer and closer and closer to 0 as the value of n gets larger and larger and larger. And so we can write this the conventional way, is to write the limit of 1 over 2 to the n as n approaches infinity is equal to 0. So we've just shown how to talk about a limit with regards to a sequence. Let's look at limits from another way. Let's talk about the limit of a function, for example. So first I'll erase this. So let's consider the situation where I have a function. Say that my function is, for example, f of x equals to x over sine x. Okay, and now what happens if I try and evaluate f of 0? F of 0 is 0 over sine of 0. Sine of 0 is 0, so this is 0 over 0. And so you might be looking at that and thinking, what on earth is 0 over 0? And you'd be right, because that is an undefined number. We can't talk about what that is. But what we can do is look at values of f that are close to 0 and see if they appear to be approaching some other number, or approaching some number, some limit. So let's try looking at that. Let's look at f of 0.25, f of 0.0625, and f of 0.001. So these are numbers that are getting closer and closer to 0. So if we look at f of 0.25, that's going to be calculated out as 1.01. F of 0.0625 is going to be 1.00065. And f of 0.001 is going to be 1.000000. That's a lot of zeros, 167. And so these numbers appear to be getting closer and closer to 1 as x gets closer and closer to 0. And we've shown, or we can talk about what f is approaching as x goes to 0 with the concept of a limit. So we can say here that the limit as x approaches 0 of f of x is equal to 1. But we actually have to pause for a second and say that we've only examined positive values of x here. We've only considered the case of x approaching 0 from the positive x-axis. So we've looked at values of x that are getting closer and closer to 0 from the positive side of the x-axis. So what we have to do now, in order to say that the limit of f of x as x approaches 0 is truly 1, is to look at the negative side of the x-axis as well. So to look at values of x for x less. So we can do that by looking at, for example, f of negative 0.25, f of negative 0.0625, and f of negative 0.001. So this first value, f of negative 0.25, is going to be 1.01, like it was on the positive side of the x-axis. F of negative 0.0625 is going to be 1.00065, and f of negative 0.001 is going to be 1.000000167, like it was on the positive side of the x-axis. So looking at this, we can see that these numbers are also approaching 1, and if you wanted to be extra careful, you could try with even smaller numbers, or values of x even closer to 0. But we can say that these numbers do appear to be approaching 1. So we can now say that the limit as x approaches 0 from the negative side of the x-axis here, as x approaches 0 negative of f of x, is also going to be 1. So now what we can do is say that the limit of f of x from both the positive and negative side of the x-axis is 1. So we can actually conclude now, based on these two examples, that the limit as x approaches 0, no pluses or minuses anymore, of f of x is equal to 1. And so now we've seen that the limit of a function is something that we can describe as well. We've seen that the limit of a sequence is also something that we can describe. So even if we don't know what a function value is, or even if we can't, define the infinite value in our sequence, we can talk about what these values appear to be approaching. And this is a really useful tool. That's limit.